Okay, geometry, this is day 3. This is the last day. We're doing the middle section, though, of the review today because we should already have 1 through 20 done and like 37 through 50 done. So we're just doing this middle chunk right here, these middle like 2 pages. So starting with 21. As soon as we're done doing these problems on the review, check back through your review, make sure you have everything on it that you're going to need, that you have everything filled in, and anything else that you want to write down. For the test, and just make sure you're all prepared for that. So, starting with 21, find x. Okay. Some of these, when we get to the right triangle trig, it's like which method do we use? What do we do? Here we're just solving for a side, and we have the other 2 sides, but we do know that this is a right triangle, so I can just use the Pythagorean theorem. Make sure you label your side C. C is 17. And so we've got a squared, I'll just call him x. X squared plus 8 squared equals 17 squared. 8 squared is 64. 17 squared is like 289. Let me check. 289. And then we subtract the 64 over. And x squared equals 225. And if we take the square root, that comes out nicely. It is 15. So if you knew your Pythagorean triples, 8, 15, 17 is one of them, then you could just skip the whole process altogether. But, it doesn't hurt to do the Pythagorean theorem. It's fine. 15 is what x is. And that should make sense. 17 should be the largest side. So there you go. Okay? All right. If I go too fast, pause it or, wait and go back through. It doesn't matter. Here we're finding sine of j, cosine of j, tangent of j. I'm going to write these out. Okay? And the angle J is very important. So make sure that you are referring to J instead of like angle L. So I'm going to circle J because we're doing everything in relationship to angle J. And all we have to do is fill in our fractions off of that angle J. So labeling the sides, we have like the opposite side would be 24. Hypotenuse is 40. And the adjacent side is 32. But one thing that I do know out of all of those is that they're all can be reduced. So I would rather reduce them here than reduce them 3 times over here, okay? So let's reduce. They reduce by 2, they reduce by 4, but they also reduce by 8. So if we want to make a really big number, we can reduce each one by 8. 32 divided by 8 is 4. This would become 5, and this would become 3. Hey, that's a 3, 4, 5. And then we can just do all of our stuff from there. So sine, write in SOH, CAHTOA. If you need to, put that somewhere. Put that at the top of the paper so that you can remember it. But sine is opposite over hypotenuse, so 3 over 5. 3 over 5. Cosine is adjacent over hypotenuse, so going to be 4 over 5. And tangent is opposite over adjacent, so 3 over 4. And that's all you have to do for those is just give me those fractions. But make sure that you're looking at the right angle. Don't accidentally circle angle L, okay? Number 23, you're solving for angle X. And this we're going to use sine, cosine, and tangent also. But I guess it's a 45, 45, 90. So we could... Do I give you a 30, 60, 90? Let's just solve it using right triangle trig. I just want to do it that way. Let's do it that way. So if you want to, a 45, 45, 90 triangle is 1, 1, and square root of 2, right? So if this side is 14, then x would be 14 square roots of 2, okay, if you can remember that. Or I'm going to show you another way. So if you want to do it that way, you can. I'm going to do the trig functions. So in relationship to 45, this is the adjacent side, this is the hypotenuse side. So we can do cosine. And cosine of 45 equals adjacent, which is 14, over the hypotenuse, which is x. Now, when the x is in the bottom, we flip places with these two. So x will be equal to 14 divided by cosine 45. And if I type that into my calculator, I get something like 19.8, we'll say. And 19.8 is the decimal version of 14 square roots of 2. So I don't care. I'll let you do it either way. Technically 14 square roots of 2 is a nicer answer because it's not rounded. But if you want to do it using SOHCAHTOA, I'm fine with that too. Either way, okay? There's that 45, 45, 90 triangle again. Okay? 24, I don't think I give you a 30, 60, 90. So if you're wondering that, I don't think I give you a 30, 60, 90. This one you have to use a trig function. So 64 is my angle, x is the opposite, 11 is the adjacent side. So we have to use tangent because it's TOA. So I take tangent of 64 equals, opposite is x, and then the adjacent side is 11. And all I need to do is multiply the 11 over to the other side to get x by itself. So I just take 11 times tangent of 64, and I get 22.6. One thing that I should mention, though, is that if you practice typing this into your calculator and you get an answer that is not 22.6, you're probably typing it in right, but you are in radians rather than in degrees. So you need to let me know that on Monday or Tuesday whenever you take this test, and I will switch that for you. So practice typing that in. Make sure that 11 tangent 64 comes out to be 22.6 for you. If it doesn't, I need to fix it, okay? And 22.6 was this side over here. And that seems appropriate. Like this side is longer than 11 because this is 64 degrees, which is a bigger angle. 25. Find the measure of angle T. So we're solving for angle T, and I'm going to put X in its spot. I'm going to put X there, okay? The two things that we know is that this is 7, and that is opposite from angle X, and 18 is the hypotenuse. So we're still using a trig function. We're using O and H, and O and H is going to be sine, except this time we have sine of X because we don't know the angle. The angle has to go inside of there, but we don't know the angle. And then we do opposite over hypotenuse because that's what SOH is. SOH. Opposite over hypotenuse, so I do 7 over 18. Okay, now, since the x is trapped inside of here, to get it out, I have to do the inverse sign. Okay, so I hit that shift button, inverse sign of 7 over 18, and it will give me the degrees of, it's like 22.9 degrees. That's what that angle x will be. Okay? All right, that's the only time you use inverse sign is when you're solving for an angle, when you don't know the angle. Like up here, we were solving for a side, so we did not use the inverse at all. We just flipped the equation around and solved. But here we do use the inverse, okay? That's 25. Moving on to 26. 26 and 27 are going to be the toughies, okay? Those are going to be the tough ones. So take a deep breath. Here we go. Solve the following triangle. That means capital A, capital B, capital C, lowercase a, lowercase b, lowercase c. Yuck. And they always give you 3 pieces of information. And this one's a tough one. So if capital A is here, then lowercase a is 22. So I'm going to put that here. Capital C is here, lowercase c is 16. Capital B is here, lowercase b is 20. So that's how you label those. They're the ones opposite, and you should know that. But if you don't, that's how it works. So we have to find an angle is the problem. And this is one where we cannot use SOHCAHTOA. We cannot use the Pythagorean theorem or anything like that because we don't have a right triangle. So this is, I'm going to put a star here, not a right triangle, okay? So your brain should go straight to, well, you have to either use the law of sines or the law of cosines, okay? You can use the law of sines if you have a group of something. We've talked about that before, where I know like A and A, or I know B and B, or I know C and C, but I don't know that. So I have to use the law of cosines, which is really gross. Okay, law of cosines, here it is. A squared equals B squared plus C squared minus 2BC times cosine of capital A. Okay, I'll give you a second to write that down. And we know lowercase a, lowercase b, lowercase c. So I know these things right here that I can plug in, and the thing that I'm going to try to find is capital A. Okay, so you really have to show all your work and write this out nice and good. This is probably maybe the toughest question on the whole test. Okay, so I'm going to plop these in for ABC. 16 squared minus 2 times 20 times, I'm going to run out of room, cosine of A. Okay. All right, stay with me because there are things that you're going to do, that you're going to try to do that are illegal, and I don't want you to do that, okay? So, don't do anything illegal. 22 squared is 484, okay? 20 squared is 400, 16 squared is 256. 2 times 20 is 40, and 40 times 16 is 640. Cosine of A. Here's where you're going to do illegal things. Don't do anything illegal. Don't do anything illegal. I can put the 400 and the 256 together to make 656, but I cannot subtract 640 from that because it is attached to the cosine. So the only thing I can do now is subtract 656 over to the other side. Okay? All right, if I'm going too fast, pause. 484, this is where I get stuck. 484 minus 656 is negative 172 equals, and then I have negative 640 cosine of A. All right, now I take the 172 and I divide by negative 640 because it's multiplied by cosine, so I have to divide it to the other side. Negative 640. Negative 640. And I get something really gross, like 0.26875. I'm going to write that better because you can't see it. 0.26875. But that is cosine of A. This is a tough problem, guys. I'm not going to lie to you. There's a lot of steps for just one little bit of it, okay? Now, if I'm solving for cosine of A, I have to do inverse cosine of this thing to get it to the other side. So I'm going to do inverse cosine of that thing. And I get, finally, I get 74.4 degrees. Holy cow. And we're still not done. But the next part's easy. 74.4 degrees. Okay. Now, the law of cosines. Don't ever do that more than one time per problem. More than once. You should never have to do it more than once. Now we can do the law of sines. Law of sines. I'm going to put it here. And the law of sines is sine of, we'll just say sine of A over A equals sine of B over B. Okay. That's what the law of sines is, and this is a lot easier to do, okay? So now that we have a group like A and A, we can use that, and we're going to solve for B, this guy, next, using our law of sines, okay? So here we go. I'm going to do sine A over A, so that would be sine 74.4 over 22 equals sine of B over B is 20. Okay, and now I have this, and now I can cross multiply, divide. So I'm going to multiply these two together. 20 times sine of 74.4. 20 sine 74.4. And I get 19.26, something like that, equals, and I'm going to take 22 times sine of B. I'm going to write that down because I can't do that in my calculator because there's a B there. And then one of the last things is divide by 22. So I take 19.26 divided by 22. And we're almost done. I get 0.8756, something like that, equals sine of B. Last thing. To get the sine to the other side, I do inverse. So I'm going to do inverse sine. This is a tough problem. This is one of the hardest ones. Probably the hardest problem on the whole test. 61.1 degrees is what B will be. And now don't be silly. Don't be silly. Add these two together and subtract from 180 to get this last one. Okay, we're thinking smarter, not harder. So plus 74.4, and then I'm going to subtract that from 180. And I got 44.5 degrees. Okay, this is solving your triangle. That's a lot of stuff. That's a lot of stuff. That might be one of your 5 that you skip, but go for it. Try it. I mean, you got nothing to lose. So one more thing that I will check, like 22 is my biggest side, 74 was my biggest angle, 16 was my smallest side, 44 was my smallest angle. So that is consistent. Like that makes sense to me. All right. Okay, 27 is another doozy. If you need to go back, like, that's a lot of work for one problem. Holy cow. Man, oh man. All right, so pause if you need to. 27, solve the following triangle. Here we go. This is another one of those, except they give you nicer information. So we still have ABC. and ABC. That's what it means when it says solve the triangle. ABC, ABC, okay? We have to write in stuff that we have. So we have 37 is A, that's a degree. 78 is C, okay? And then the only other thing they give me is 12, and that is little c because it's opposite capital C. So 12 is that guy, all right? And then, don't be silly, add these up and subtract from 180 to find capital B. So 37 plus 78, I'm going to subtract that from 180, and I get like 65 degrees is what that one is, okay? All right, so this one we get to skip using the law of cosines, which is the ugly one. That is gross, gross, gross. And we get to go straight for the law of sines. I'm going to put them here. Law of sines, which is sine A over A equals sine B over B. This is a lot nicer of a problem, okay? So, and actually in this case we have to use C because that's the grouping that we have, okay? So I'm going to start with sine of 78. So we're really doing sine C over C. Sine 78 over 12 equals, let's find A first, okay? Sine 37 over A, okay? So I'm going to cross multiply, and I'm going to multiply these two first because I know those, right? So 12 sine of 37 is something like 7.22, and that equals A times sine of 78. Okay, now some of you don't write out all this work, and I don't blame you because it's ugly. You just go straight for dividing, and that's fine. Like if that makes sense in your head, just do it. So 7.22 divided by sine of 78, and that is 7.4. If we go one decimal place, 7.4. So that's what my A is. Okay, now I'm going to do the same thing with B. At this point, I found lowercase a is 7.4, so that's this side over here. At this point, I'm going to ask myself, like, can I do the Pythagorean theorem? Because I have two sides and I want to find the third side. I don't know, can you? You should be saying, like, no, you can't because it's not a right triangle. Okay, so this is another non-right triangle. You can't do that. So we've got to do the same process again. We can't do any cheating methods or anything like that. So we're going to use this same, like, I don't know, proportion right here. With the sine 78, we'll still use C. Sine 78 over 12 equals, but this time we're going to do sine of 65 because we're doing B. So sine 65 over B, okay? And now we cross multiply again. Cross multiply, divide again. Whew, if I can talk. So 12 sine 65 this time is 10.88, we'll go, equals B times sine of 78. Again, if you skip this step, I don't blame you because you're just going to turn around and divide by sine 78. That's why it's cross multiply and divide. Okay, 10.88 divided by sine 78. I got 11.1. Now, if you get a different answer than me, it's probably because you used 10.88. I used the actual decimal number that was like full in my calculator and just divided by sine 78. So like my answer is like really super accurate. But if you got like 11.2 or something, that's probably what you did. You just typed in 10.88 again. Okay, so solve the triangle. That was a lot faster than 26 was because you got to skip the law of cosines. You could go straight to the law of sines, but still a lot of work, okay? So if you are one of those people that wants to answer all of the questions, all 50 of them, and not skip any, you might have to study over those two, okay? All right, 28, here we go. We're almost, we still got a page left. Whew. We got lots to go. All right, 28. Determine whether the following creates a right triangle, an obtuse triangle, or an acute triangle. Okay, so if it's a right triangle, we know that a squared plus b squared equals c squared, okay? But we could also use that formula to determine obtuse or acute, and here's how we do it. You want to make sure that you know which side is side C, and it's not always going to be the last one. Like in this case, it's not the last one. Side C is the biggest side. Side C is this one. So that's the one that you want to pay attention to, okay? So I'm going to do 18 squared plus 27 squared. And I'm going to do like, what is that in relationship to 31 squared? Let's figure it out. So 18 squared is 324. 27 squared is 729. I don't know these off the top of my head. I can't do these. 31 squared is 961. Okay, if I add these two together, I get something crazy. Like 324 plus 729 is 1053 if I add those together. Okay, what are those in relationship to 961? Okay, this is bigger. Okay, this was my biggest side. All right, this was my side C, but my side C is small, right? It's on the small end. So C is a small one, which means that my biggest side, like if I'm making a triangle and like this bottom is my biggest side, it's still fairly small in comparison to the other two, right? So that means this is going to be an acute triangle, right? If my biggest side was a big side, right? Like this right here, if this side was my big side, I would have an obtuse angle, right? So this is an acute triangle because my biggest side is still a small side. And that's how you can determine whether it's obtuse, acute, that type of thing, okay? All right, moving on. All right, I'm trying to go as fast as I can, but I want to make sure you get all this, okay? Chapter 9 circles should be a lot less, or like they should go faster, okay? 29. Labeling this is going to be the hardest part because you get messy things going on. They want us to find YB, so I'm going to write down what we're trying to find so we don't get lost. The diameter of A is 10, which means the radius is 5. I'm going to write that down. The diameter of circle A, and the radius of A goes from here to here, so I'm going to label that as 5. Okay, that's the radius of A. Then it says the diameter of B, I'm fuzzy, is 8, which means the radius is 4. So for circle B, this guy from here to here is 4. And then they tell me one more piece of information, and that is that AX, which is this guy right here, that is 3. And now I have all my labelings that I need in order to figure out other stuff. So if this is 3, then that means that this guy has to be 2 because they add up to be 5, okay? And if that's 2, then this has to be 2 more because those add up to be 4. So they were asking us for YB, which is this guy over here, and that is 2. I'll zoom in again. YB is going to be 2. Okay, you just work backwards and try to get those values figured out, all right? But be careful when they say that the diameter is 10 and the diameter is 8 because you need to know the radius instead, okay? All right, 30, working backwards. They say find the radius, and they give you the circumference, okay? Circumference of a circle, remember this formula, is 2 times pi times the radius. I'm going to say or diameter times pi, but since they're asking for the radius, I'm going to use this form of it, okay? But they're telling me that 2 pi r, the circumference, is equal to 36. They're telling me that's equal to 36. And then they're just saying find the radius. So if I'm trying to get the radius by itself, I would just divide by 2 pi. It's all algebra, right? Dividing by 2 pi. So the radius is 36 divided by 2 pi. 36 divided by. Okay, now when you type this into your calculator, I know you're going to type it in wrong. Because if you just take 36 divided by 2 pi and don't put parentheses around the 2 pi, it's going to take 36 divided by 2, and then pi is times that. So it's going to do this first. Okay, so when you type this in, if you're getting a wrong answer, you're not getting what I got. It's because you didn't put parentheses around the bottom. So 2 pi goes in parentheses. And the radius should be like 5.7. 5.7 meters. Okay, if you did not get that as an answer, it's because you didn't put it in parentheses. You can also do instead 36 divided by 2 divided by pi, right? If you want to type it in that way, because the 2 and the pi are in the bottom. So just to be clear, you got to make sure you do the parentheses right or divide, okay? 31 is DC. DC is this arc right here. Is that a major arc, minor arc, or semicircle? And find its measure. Okay, so DC is going to have the same measure as this central angle, which is going to be 100 degrees. So find its measure. The measure of DC arc is 100. We found its measure. But is it a major, minor, or semicircle? Major arcs are more than half the circle. Minor arcs are less than half the circle. Semicircle is actually half the circle. So this is a minor arc. Now, some people get that confused because 100 degrees, they're thinking, well, 100 degrees is an obtuse angle because it's more than 90. It has nothing to do with that. Is it more than half the circle or less than half the circle? It's less than half, so it's a minor arc, okay? There you go. Or you can write like minor is less than 180 degrees because that's half a circle, and major is more than 180 degrees, okay? There you go. All right, we've got a couple left. Good heavens. 32, find the measure of arc LM. They're saying like find actually how big this is if the radius is 5 inches. So yes, I know that this is 100 degrees, but like distance-wise, how many inches is that, all right? So they're asking me for circumference, right? Circumference is 2 times pi times r. If I were trying to find the circumference of the entire circle, I would put 5 in for the radius, so this entire circumference is 10 pi. But I only want this chunk. I don't want the entire circumference. I just want this chunk or this pi crest. So I'm only looking for 100 out of 360 degrees. Okay, so take 10 pi times 100 over 360. 10 pi times 100 over 360. And that is like 8.7 inches. That's what that is. Okay? All right. If you guys need to take a break and pause, please do. This is going to be kind of a long video because this middle section, that first part was a lot. Okay? All right. I'm going to let's talk about 35 first. Let's do that one. This one's easier. 35. Find x and then find the perimeter. Okay, when we talked about these, I talked about the different ice cream cones, okay? So like looking at this as an ice cream cone, these are tangent lines to that circle, right? They're touching at one spot, tangent lines to the circle. So this guy's 14. This guy's also going to be 14 because your ice cream cone has to be the same size. If this is 18, this has to also be 18 from here to here, okay? And if that's 18 and the whole thing is 26, then this has to be, what, 8? So x is 8. X equals 8. And then they want the entire perimeter, okay? So I'm just adding up all the sides. So we know that this side here is 26, okay? This bottom side here is 18 plus 14, which is 32, I believe. And then 8 and 14 is 22, and then I add them together. So 22 plus 32 plus 26. 0, carry the 1. Oh, my heavens. 8, 80. 80 something, 80 units. That's the perimeter. Okay, I think I did that right. Yeah, I think I did that right. So 35, that's it. All right, now these three I'm going to do like kind of all at the same time because they all kind of have whatever formula, right? So here we're solving for angle y, which is outside the circle. Write that down. Outside of the circle. The angle is outside of the circle. 44, we're solving for angle r, which is on the edge of the circle. Okay, that's important, on the edge of the circle. Here we're solving for angle 2, which is inside the circle. Okay, so when we did these in class, when they're outside the circle, you subtract and divide by 2. Okay, so I'm subtracting these arcs and dividing by 2 to get y. Okay, so 105 minus 63 and divide by 2. When it's outside the circle, you subtract and divide by 2. Okay, 105 minus 63 divided by 2 is 21 degrees. That's what y is, which seems about right. Like it's a smaller angle. Okay, I'm going to go down to 36. When it's inside the triangle, you are going to add and divide by 2 because you're like finding the average, right? Add, divide by 2. So the things that we're adding is 48 and 38. Okay, 48 plus 38 divided by 2. 48 plus 38 divided by 2. And that is 43 degrees, except 43 degrees is going to be each of these, right? Because it's like going horizontally. Like these arcs are corresponding to these two angles, right? So if I'm trying to find angle 2, I look at this as like being a straight line here. 43 is this guy. I have to subtract from 180 to get angle 2. So I'm going to take 180 minus 43. And that is 137 degrees. There we go. Okay? Oh man, that's a lot. This one, we just divide by 2 to get when it's on the edge. You don't add divide by 2, you just divide by 2. But if we're trying to find angle R, we need to take this arc divided by 2. Huh. So, a little bit of critical thinking here. We've got 120 is this arc, 140 is this arc. If we add those two together, that is 260. But all the way around the circle is 360. Okay, so that's going to be 100 degrees. This guy is 100. And then we divide it by 2 to get that one. So angle R is going to be just 50 degrees. Okay, so I hope that was not too fast. If it was, pause. You could go back in the video. I don't care. This middle section might have been the hardest section of all 3 of them. I don't know. Just because maybe that first one, that 26 and 27 or whatever it was, those were yucky. So don't let that discourage you. Those are 2 hard problems, okay? Look back through your packet. Make sure that you have everything ready to go for your test on, you guys will be on Tuesday, 1st and 5th period on Tuesday. So make sure you have everything ready to go. If you have questions, email me or message me on Google Classroom. I don't care. Let me know. All right. Check through your packet.